Hello students, my name is Professor Muhammad Asim and we are doing AdMath. AdMath for IGCSE students which have syllabus code 0606 and for CIE O level students which have syllabus code 4037. So both kind of students can get equal benefit from this course. Students, in last lecture we started exercise 11.4. We did question number 1, 2, 3, 4 and 5. The topic of this exercise is geometric progression or geometric sequence. Today we are going to do some more questions from this exercise, but before I start, I would suggest all those students who are watching my lecture first time, kindly first go to my playlist. There is a folder name is AdMath. Watch previous lectures. After watching previous lectures, you will have good command on this topic. Let's start question number 6. The 6 and 13 terms of a geometric progressions are 5 upon 2 and 3 upon 20. So in this question, the 13th term given T13 is equals to 5 upon 2, the 6th term, that is T6, is given 5 upon 2 and 13th term, that is T13, is given 320 respectively. Find the common ratio, that is we have to find R. The first term, that is T1, and the 10th term, that is T10. So we have to find three terms, three numbers, R, T1 and T1, or we call this is A, because in any sequence the first term we call is A. So it is very easy. We know the formula of nth term is an is equals to a dot r to the power n minus 1. Dot r, dot means multiply, or instead of an it is comfortable to write tn, because we wrote t6, t13 and we need t10. So throughout the exercise I will use, instead of an I will write tn, no difference. So first we have to find t6. T6 is equals to a r to the power 6 minus 1, and the value of T6 is given 5 over 2 a r 5. 6 minus 1 is 5. Now we find T13. T13 is a dot r to the power 13 minus 1. T13 is given 320 is equals to a r to 12. So we have two equations, equation number 1 and equation number 2. If we divide equation number 1 by 2, that is a r 12 upon a r 5 is equals to 320 upon 5 upon 2. A cancel by a, r 12 minus 5 is 7. 320 by 2 is 680 upon 5. Six 80 upon 5 is 136. 680 upon 5 is 136. So R7, r to the power 7 is equals to 136, and we have to find r, not r7. So how it is possible? Kindly wait, first I will solve myself. Sorry students, 320 into 2 is 640. 640 upon 5. It is 128. And 128 can be write 2 to the power 7. So according to the rule of indices, if bases are different and powers are same, then we can say bases are also same. Hence R is 2. So first requirement has fulfilled. The value of R is 2. How to find the value of A? Put the value of R in any one of the equation number 1 or equation number 2. So I am putting the value of R2 in equation number 1. So 5 upon 2 is equals to A. R is 2 power 5. So 5 upon 2 A, 2 power 5 is 32. So 5 upon 2, this 32 should be divide and multiply by 2. So A is 5 upon 32 into 2 is 64. 64. So this is the requirement of second requirement. A, the first term is 64. Now Tn formula you know, A r to the power n minus 1. The last requirement is to find the 10 terms. So T10 is equals to A, we have find 5 over 64 dot. A we have R we have already find 2, n is 10 minus 1. So 5 upon 64 into 2 power 10 minus 1 is 9. So 5 upon 64 is, you can say, 2 power 6 into 2 power 9. Now 5 into 2 power 9, 9 minus 6 is 3. This is the rule of indices. 5 into 2 power 3 is 8 and 40. Hence T10 is 40. So this is our final answer. All three requirements has fulfilled. The common ratio is 2. The first term is 5 upon 64 and the 10th term is 40. Here is the summary of the entire question. This is the summary. So hope you understand. Now move to question number 7. Question number 7. The sum of the second and third term in a geometric progression is 30. It means T1, second term means T2 and third term means T3 is equals to what? 30. Next, the second term is 9 less than the first term. It means the difference between T2 and T1 is 9. So you can write T1 minus T2 is equals to 9. Given that all the terms in the progression are positive, it means no negative term in the sequence. Find the first term. That is, we have to find A. Student T2 if you use the formula Tn is equals to ar to the power n minus 1 and replace n by 2, you will have ar. And again, if you use the formula Tn is equals to ar to the power n minus 1, you will have ar square is equals to 30. Similarly, T1 means A, the first term, and T2 is what I told you, AR is equals to 9. Taking common A from this expression, so it is R plus R square is equals to 30. And taking A from these two, we will have 1 minus R is equals to 9. Or we may write A is equals to 9 upon 1 minus R. Now put this value 9 upon 1 minus R over here. So A is now 9 upon 1 minus R. R plus R cube is equals to 30. Now if we cancel this 9 and 30 by 3, it is 3 ones are 3, 3 3s are 9 and 3 10s are 30. So 3 into R is 3R. Sorry, this is not R cube, this is R square. And 3 into R square is 3R square. And this 1 minus R should be multiplied by 10 because it is divide on left hand side. So 3R plus 3R square is equals to 10 ones are 10 and 10 into R is 10R. So 3R square plus 3R plus 10R 10R and minus 10 is equals to 0. So 3R square 10R plus 3R is 13R minus 10 is equals to 0. This is a quadratic equation and I will solve this quadratic equation by using middle term break method. If you don't like middle term break method, no problem, go for quadratic formula. So 10 3s are 30, 15 2s are 30, 15 minus 2 is 13. So 3R square plus 15R minus 2R minus 10 is equals to 0. Taking 3R common from first two, it is R plus 5. Taking minus 2, it is R plus 5 is equals to 0. Then R plus 5, 3R minus 2 is equals to 0. This implies that R is equals to minus 5 and 3R minus 2 is equals to 0 means R is equals to 2 upon 3. And we will take only this R because according to question, what they have given that all the terms in the progression are positive, so we will not take negative R. Find the first term. This is the question. So put this value of R in this equation. Assign the name is equation number 1. So A is equals to 9 upon 1 minus R. 1 minus R. R is 2 upon 3. So 9 upon 1 minus 2 upon 3 is 1 upon 3. And this 3 should be multiplied by 9. 9 3s are 27. This is our final answer. Very good question according to examination point of view. Good concepts. So 27 is the final answer, the first term requirement of the question. This is the requirement. And this is the whole summary of question number 7. I hope you understand. Now move to question number 8. Question number 8. Three consecutive terms of a geometric progression are x, x plus 6, x plus 9. Find the value of x. The easiest question in this exercise, because this is a geometric progression. If this is a geometric progression, then it has a common difference. That is, x plus 6 upon x must be equals to x plus 9 upon x plus 6. This is the difference. This is the common difference. And how to this is the common ratio. And how to find ratio? Divide every preceding term by its following term. Cross multiply x plus 6 into x plus 6, x into x plus 9. So it is x plus 6 whole square, x into x square, x into 9 is 9x. Expand this by using a plus b whole square formula. X square plus 12x plus 36 is equals to x square plus 9x. X square cancel by its x square. 12x minus 9x is equals to minus 36. 12 minus 9 is 3x is equals to minus 36. So x is equals to 3 into minus 18, minus 12 is minus 36. That's why I told you the easiest question of this exercise. This is question number 8. Move to question number 9. Another very interesting question. In the geometric sequence 1 upon 4, 1 upon 2, comma 1, comma 2, comma 4, which is the first term to exceed 500,000? Students, this is the geometric sequence. So you can see its every number is double. That is 1, 2, 4, 8, 16 and so on. So there is a term which has value is 500,000, greater than 500,000. So there are so many values, but the first value at which term, when first value is greater than 500,000, it is very easy. Actually, a is first term, 1 upon 4. R is divide any preceding by its following, that is 2 upon 1 is 2. We have to find n. This is the main thing. Which is the first term means we have to find the value of n, and we have to write that this 500,000 is the value of the last term, because after this term the value is, because at this term the value is exceed 500,000. Okay, so the formula is Tn is equals to a r to the power n minus 1. Tn we have to put 500,000. A is 1 upon 4. R is 2 to the power n minus 1. Now we need what? We need n. So this 4 should multiply by 5. It is 20. Then 20 100,000 is equals to, break this 2 power n minus 1 in terms of 2 power n dot 2 power minus 1. And then 200, 2, 3, 4. 2 power n. This 2 power minus 1 can be write in terms of denominator, that is 2 power plus 1, and multiply this 2 by this huge value. 2 to the 4, 400, is equals to 2 power n. Now we need uh, 2 power, we need the value of n. So we have to, first we have to write it's 4 into 1, 2, 3, 4, 5, 6. 4 10 is to power 6. It is very easy. In order to find n, taking log on both sides. The logarithm is the best tool. So log 4 10 is to power 6 is equals to log 2 power n, or log 4 10 is to power 6. Power always write before the log, and finally log 4 10 is to power 6 upon log 2 is equals to n. Use scientific calculator to find the final answer. The answer is 21.93. The answer is 21.93. And you know, the number of terms can never be in decimal form, so n should be 22. So at this term, the value is exceed 500,000. If you want to confirm, if you want to check that my answer is correct or not, just put T20 n is equals to 22 in the formula of Tn a r n power minus 1. A is 1 upon 4, r is 2, n is 22, 22 minus 1. You can easily check that at this value of number of terms, the answer is greater than 500,000 or exceeds. Now move to question number 10. Question number 10, in the geometric sequence 256, 128, 64, 32, 256, 128, 64, 32, dash dash dash, which is the first term that is less than 0.001? Again, we need to find the value of n, just like we did in question number 9. So the first term is 256, the r is 128 upon 256, that is 1 upon 2, and we have to find the value of n, and Tn is given 0.001. What is the formula of Tn? You must remember, keep in your mind, Tin is equals to ar to the power n minus 1. Here Tn is given 0.001, a is given 256, r we have find 1 upon 2 to the power n minus 1. So 0.001 is equals to 256 dot 1 power n minus 1 is 1, and 2 power n minus 1 is 2 power n minus 1. Next, shift this 2n power minus 1 over here. It is 2 power n minus 1, and this 0.001 should be divided. Next is 2 power n dot 2 power minus 1 is equals to 256 upon 0.001. 2 power n, and this 2 power minus 1 becomes 2 power plus 1. 256 upon 0.001. Then 2 power n is equals to 256 into 2 upon 0.001. Now use calculator. So 256 into 2 divided by 0.001 is 512000. 512000. Again we have to take logarithm on both sides, and this time I am writing directly n is equals to log 512000 upon log 2. Use calculator to find the value. The answer is 18.96. The answer is n is equals to 18.96. Again, n cannot be in decimal form, so it should be n should be 19. This is our final answer. So hope you understand this interesting question. The whole exercise is very easy and very interesting and very important according to examination point of view. Here is a summary of the question number 10. That's it. This is our today's class. How many questions are left? Question number 11, 12, 13, 14, 15, 16. And these questions are related to some of geometric series. But student, these are very easy questions, just like question number 8, 9, 10. I promise I will do each and every question, each and every part. So that's it. This is our today's class. If you like my videos and if my videos are helping you, kindly do subscribe my channel, and whenever you subscribe, don't forget to press the bell icon button so that when I upload my videos you will get the notification. Kindly share my videos as many as you can. Okay students, good luck for next lecture.